All right. What is going on, everybody? It's Advent of Code 2024, day 19. About to get started here in a few minutes. Just make sure everything's running. That's the wrong day. Seems to be working. And there we go. All right. 3 minutes here before we get started. Right. Oh, thanks, Tyler. Appreciate that. See how today goes. Yesterday I could have been done a lot faster. I mean, I wasn't super long. About to get started here in a second. All right. All right, here we go. Day 19. Linen layout. Today the historians take you up to the hot springs on Gear Island very suspiciously. Absolutely nothing goes wrong as they begin their careful search of the vast field of helixes. Could this finally be your chance to visit the onsen next door? Only one way to find out. After a brief conversation with the reception staff at the onsen front desk, you discover that you don't have the right kind of money to pay the admission fee. However, before you can leave, the staff gets your attention. Apparently, they've heard about how you helped at the hot springs, and they're willing to make a deal. If you can simply help them arrange their towels, they'll let you in for free. Every towel at this onsen is marked with a pattern of color stripes. There are only a few patterns, but for any particular pattern, the staff can get you as many towels with that pattern as you need. Each stripe can be white, blue, black, red, or green. So a towel with the pattern GGR would have a green stripe, a green stripe, and then a red stripe in that order. You can't reverse a pattern by flipping the towel upside down, as that would cause the Onsen logo to face the wrong way. The official Onsen branding expert has produced a list of designs, each a long sequence of stripe colors that they would like to be able to display. You can use any towel you want, but all of the towel stripes must exactly match the desired design. So to display the design RGRGR, you could use two RG towels and then an R towel, an RGR towel, and then a GR towel, or even a single massive RGR towel. Assuming such patterns were actually available to start the collection together, all of the available towel patterns in the lists of desired designs, your puzzle input, for example. The first line indicates the available towel patterns in this example. So I think that's what this is. This first line here. The Onsen has unlimited towels with a single red stripe. Unlimited towels with a white stripe and then a red stripe, WR, so on. Okay. After the blank line, the remaining lines each describe a design the Onsen would like to be able to display. Okay, so like that. Next example, the first design, BRWRR, indicates that the Onsen would like to be able to display a black stripe, a red stripe, a white stripe, and then two red stripes in that order. Not all designs will be possible with the available towels. In the above example, the designs are possible or impossible as follows. BRWR can be made with a BR towel, then a WR towel, and then finally an R towel. BGGR can be made with a B towel, two G towels, and then an R towel. GBBR can be made with a GB towel, then a BR towel. BGBR can be made with, okay, so on and so forth. UBWU is impossible. Okay. In this example, 6 of the 8 designs are possible with the available towel patterns. To get into the Onsen as soon as possible, consult your list of towel patterns and desired designs carefully. How many designs are possible? Okay. What's our puzzle input look like? Okay. Let's go ahead and grab this now. Wrong day. Close all of these here. Go day 19. Just go ahead and place this now. Go back and get our test input. And our value for our test input is 6. So we can go ahead and set that now. Yeah. Okay. So let's see here. I think what we can do is just kind of, we can create a map of our initial like stripes so that we have those values, and we can start with the first letter and we can move the index forward, and we can see, we can branch for each value. We can see what starts with the R, then the RW, and we can keep expanding out. The only thing is, how do we know that if we start and we start with one letter, which is a B, how do we know that we can look for an R and then an RW? And then we would essentially have to check every single permutation to make sure that there's not something there. If we look at the actual input, I mean, these are pretty lengthy. Okay. So if these are in a map, then we can just walk these forward. So we start with the first one, and we create an index moving forward, and then we can we really only need to know if it's possible once. I guess we could kind of take note of the longest character. The other thing we could do potentially is we could take this structure, this initial like pattern set, and we could organize them in such a way that we can start at W and then we can see if what all the possible like paths we can take. That might also be a possibility. But I think we can just start simple and say, okay, is there an R? Okay, there's not. Is there an RW? Okay, there's not. Is there an RWR? Okay, great, there is. That gets added. And then so on and so forth. Then we can start with, okay, send U, etc., and only any valid path with a valid index would then get added. Maybe. But I feel like if we're checking each character each time, that can just become very inefficient. So yeah, I wonder if the strategy is to not just treat each of these, because we could walk this much faster, right? Like if we have an R, then if we know that node, we could just walk them forward instead of checking each one. But let me just do the first part. Let me just see. Let's start putting something down here. So that's our sections, and then the first section is going to be a strings.split, and that's going to be sections sub 0, and we're going to split that on comma, and that's going to give us our first. Let's do comma space. Just go ahead and take care of that now. And we'll call this our and then our patterns are going to be And then we've got that. So that should be our patterns. So if we do a make sure we actually have the values. Yeah, so perfect. Okay. So if we do something like and if we could say something like so we want to start at I and okay. Mm, um I want to move the pointer of I forward, but I want to change the branch each time. Something like that. And then, because we're looking at a specific pattern, and then we're going to take this and we're going to then say, trying to think of how I want to do this. I feel like if I try to do some sort of like queuing mechanism with the pattern, so I want to do something with the particular index, and so I want to add the index for each index that has a particular match. But I got to start at the the int the index and essentially walk forward a j index all the way to the end of the list, and only for anything that matches. And then once I get to the end, so something like that. So but only where the previous index has matched something, right? So meaning that what's in the queue is really our starting point looking forward until we get a match, right? So once we get all the way to the end, we have a match, we know that we're good. But we're basically creating this queue of, but I don't necessarily want to do that because I don't know if it would be better to be recursive here or not. Um, so we start here and we say, okay, do we have a B? We have a B, so we can add R to our queue. We look starting at R, we have an R, we go to W, we look and see, okay, there's no W in the queue. So then we move forward and we add WR, or we look at WR. WR we do have, so then we add the final index of R. We look and we have an R, and then we can be complete. Now, the first iteration through, yeah, I don't want to use a queue. I think what we can do is, as we find this, we go ahead and check for this, and we go ahead and check for this, and then this, and so on and so forth. So we expand it as far as we need to. We'll call this, I don't know, RP. Maybe. And then this can be moved to here. And this can be this, and this can be this. And then this is going to be something like this. And then J is the same thing. Is it easy peasy? I'm like super tired, so I know nothing. I don't I know no sense of easy. Are you already done, Tim? Um, yeah, that's awesome. That's pretty good. And then, well, I glad somebody's confident in me. Um, well, yeah, so that is not what I want to do entirely. So I actually want this to be and this to be sub something like that. Three, two. Mm, yes. Yes. I was waiting for you to chime in. I knew you would have already been done pedantic. Yeah, I'm very slow today. I don't know. I'm tired. I've not been sleeping well, so and I'm, you know, not great at these things. 3, 2. That's funny. Yeah, it's bad. So let's see here. What am I doing wrong? Should be pretty. Let's see what we actually have right before it crashes. Well, that's interesting problem to have. Um, oh, do I have these flipped? That's why. Yeah, yeah. Those are the actual towels. And then as far as my test input, doesn't make any sense. That is because this needs to be this. It's better. One zero. That is because one zero. One zero. So why didn't that not happen on the other ones? It's because they were matches. Like UBWU is not a match. It's the first impossible one. Okay. All right. Well, that's part of that. So if so, they both started at J, but okay, this has to start at I. That's the issue. Okay. Yeah. Right. I don't need all that output. Yes. Yes. Cache it is. Appreciate that. Barbie on Netflix is an interesting choice, but hey man, more power to you. How fast are we getting through these? That's really my only question here. Is it terribly slow? That's not terrible. Yeah. Okay. So how many of these are there? 402. Okay, that's interesting. That particular one's a problem. So I see I kind of get this sense that it's pathfinding. Um, Interesting that it's kind of, I don't want to say stuck, but on a particular one here. I'm just kind of curious about what particular. So 157. So what my thoughts are is that what I'm doing right now is I'm starting at W and then trying WR, then WRU, then WRBR, etc., and I'm trying every iteration all the way through, and that's not work. That didn't work. So once I get through, once I get through WR, I am then passing. Let's say I have a W, I then pass R, then RU, then RUB, etc., and then I'm redoing that over and over again, so on and so forth. And so, yeah, yeah. And so what I'm doing is I'm right now the way that I'm processing is I'm revisiting all of those sub nodes like as I'm searching. And so I'm if I have a W and I also have a WR, I am reprocessing everything after that I've already processed in a previous search until I may or may not have found a particular instance. So okay. Okay. Yeah, okay. That's fair. I mean, I okay. So I sort of am doing that already, but not exactly. Yep, yep, yep. Okay. Well, right. So okay, so I'm doing a recursive search, right? And instead of I'm passing the index, right? So I'm basically going through and I'm saying from I to J, check to see if it's in this map of towels, right? Which I have as P right now, but probably better represented as T. And if it's in there, yeah. Yeah. So I thought about using that initially, but what is T? So T is a unique map of the list of towels, right? So initially I read those in, I put them in here. That's a unique set of those are the towel or the towel patterns, right? And so the idea is here, and I'm just walking through my logic set. Of course, for some reason it's particularly inefficient, so I'm missing something here. I understand that, but I start at position 0 on the first iteration, and I move index J starting at 0 forward some number of characters, looking to see if it matches a towel. Why do I need a map? I don't really need a map. I could have used a slice of towel. That would have been fine too. Um, so once it finds a position where it matches, um, I just want something that was like a unique set that I could iterate through. I could use slices and do that as well. Um, but it's easier to check a map like just by passing the key of it. But only if the I through J matches that towel or it matches a towel, do I then recursively call find? If it doesn't, it moves the J index forward and continues to do that. The thing I'm missing here is I just don't have a way to say I've already visited this I location previously and I don't need to check it again because we're I'm doing a lot of reprocessing. I think that's all I'm missing here. And then if I add that, then I think this will be fine. Well, okay. Yeah, I mean we could do that. I mean, what's the advantage? Yes, I would say each subcall to find would be smaller. we'd have less things to check. We could always start at index 0. We don't have to have a start position, but I don't. I'm just trying to understand the advantage of changing to that versus what I have here, other than this isn't working. So obviously there's something wrong here. So I'm not saying it's right. I want to understand before I make a change to my approach. So I mean, I guess we don't have to do any sort of index any things if we do it that way, is what you're saying. So this would work. Yes. Yes, exactly. Exactly right. Uh, yes. What's that? Do the trimming? No. I think this is fine. I think it'll be fine. I'm gonna do it. We'll relabel that later. And then we're going to split this up. We're going to do a not here. And then we are going to do a we're not going to record that there actually. We're going to do it here. And then we're going to say we'll go with that. See what that does. All right. Well. What's the? Let me go back to my test. See if this still works. That's still right. Yeah, so an empty struct is definitely more efficient. It's the smallest possible thing you can go. But I'm just using a bool because it's not that much more data. So I ever only want to enter a starting point once. But it can't be S. It's got to be S of, this has to be yeah. It'd probably be better if I trim at this point, but I'm not going to because I want to I don't remember what my previous answer was. 397, 397. Okay. So nice. Sorry. Minus 30% speed improvement. I mean, is that it was 30% faster by using indexes? Okay, yeah, I need to figure out what I'm doing wrong here. Yeah, the positive and the word reduction at the same time is tripping me up. So there are 402 of these. 402 minus, so that is 399. Yeah, 399. So I'm only failing two of them? Hmm. If it's not in the towel list, we continue. We're going to keep expanding J out. J should be the next index. Well, the index is, I mean, you could just pass the string as a pointer and then you just walk it like I'm doing here. I'm missing something that is relevant. It's not. Yes, this one actually gets to the end. Oh, I know what I'm doing wrong. Jeez, Chris. Yeah, this needs to be embedded in here. That cache needs to be recreated each time. Okay, that wasn't it. Just turn this off so there's less confusion. So we're saying at this start index moving forward, we've seen this before. Is it because I'm assuming that if we've seen this before, that it's false? No, because I'm assuming that they're not all true. Maybe they all are true. J plus 1. Yeah, the cache actually could just be an index. Yeah, but I'm failing something here. I'm not sure what yet. I is less than length. J is less than length. J is always equal to I. J does not need to be equal to I. Does it? Yes. Does that start? Actually, we don't even need to iterate on I, do we? Yeah, I think that's my problem. J doesn't need to be here. I'm not even sure why I'm using J. It's fine. Nobody knows. I don't know. You don't know. Nobody knows. I think I can still use I. So I is a starting location. We iterate forward for I number of iterations. And it's going to check any of those to see if they're in the towel set. And if they are, if they're not, we continue. Otherwise, we attempt to find at that I location plus 1. I probably am. I most certainly am making it more difficult than it needs to be. All right, I'm game. So Happy? Staff don't really like some of the towel arrangements you came up with. To avoid an endless cycle of towel rearrangements, maybe you should just give them every possible option. Here are all the different ways the above example design can be made. It can be made 6 different ways. Can only be made with BWU, so on and so forth. Adding all of the ways the towels in this example could be arranged into the design yields 16. They'll let you into the onsen as soon as you have the list. What do you get if you add up all the numbers of the different ways you can make each design? I can if I want to. So I forgot what day 10 is already, but it's okay. I'll go back and look at it. Yeah. I think it's a little bit different. I think the answer is just that it's just this. So I changed my shift keys around, and now what was a shift is now a tab key, and it is not doing well for me. I need to make it turn it back. I think really it's just this, and then instead of just a single find, the initial find, because I am doing recursively, which maybe I don't need to. This is just returning a true. Yeah, I just need to, this isn't going to work because this initial set here, this is like the least efficient way to do it. But since I'm already here and already committed, I'm going to do it. Get rid of that. Get rid of that. And then for each, it's actually M up here because why? I don't know. And then trim prefix of the pattern because I'm wrapping this outside of it. And this is M, this is cache, and that is score. And if I look at my test, the answer for the test is 16. And let's see what I get here. Actual 47. Yay. The last thing here is okay. What do I have? 47. For each pattern that I'm looking for, go through all the towels, trim off the initial set. And if that is found, here, let's get rid of this index. Don't need this anymore. Start is part of the problem now, I think. Yeah, that's okay. Let's get rid of this. Let's simplify this. This isn't needed anymore. This just needs to be S and S. And we can actually just get rid of this. And return true. And we'll fix our other problems real quick. Pretty sure that's still 338, which was my initial 338. So then that's working, we'll say as design. So this is all the different initial paths. So why do I get 47? Go with This is all the different starting towels. The only thing I'm not sure on is, are we looking at, I don't think it would be possible for us to look at duplicate patterns, just because we would start all of the R's and only if finding of in the cache. Two. I'm adjusting the cache for each iteration, which that should be right, because if there are 10 paths that all start the same, or they would all trim once, and then we would get each subpath. So why am I getting, why's my number so high? There's something wrong with my test. Part 2, 16. Same test file. This would be R, would be RB. R would be another path. This isn't counting all the, this is just counting the, let's go, and I'm almost, all right, I'm working on part 2 right now. Dragging it on way longer than it needs to drag on, apparently. So this is only going to count the top level iterations. But why do I have for each pattern, for each iteration of, sorry, let me back down to part 2. For each pattern, for each key, count the number of branches, but we have to count the number at each find. So then find itself actually needs, I need a separate find. Oh, yeah, I can help with that. So I was going a slightly different path, and then Pedantic gave some very polite direction. But part one, you based on your input, you basically break the file into two sections. You have your towels at the top, and then the patterns you're trying to match. And I decided to use a map instead of a slice here, although it doesn't need to be a map. But I took the towels and I put them in a unique set, and then for each pattern, I am calling this find function given that pattern and the set of towels and then a cache. And every time the find returns true, we increment the score. So if I dive into the find function, what that essentially is doing outside of the cache here is looking through all of the towels and taking the input string and running a trim prefix on it, getting a new string, and then passing that recursively to find, which it doesn't need to be a recursive function. That's just the way that I did it. And should probably change it. At any rate, um, the the iteration here is just simply that. And then one last bit is caching the previous strings that we already saw, so we don't reprocess the same string over and over and over again. If we've gotten there from a different avenue, we can say, hey, we don't need to reprocess this. We've already seen this string previously. And so that was pretty much that. Does that make sense, Vegeta, or do you have other questions? Yes, that solved the example case. I have a separate test case that I'm working on for the second part, but that does solve, yes. So if I remove this, you can see we passed the test here, which is that sample input here. Couple of key takeaways is just making this string trim prefix trims it and creates a new string. And then I'm, recursively calling it on find itself until that string becomes empty, in which case we return a true. But I think in this case, I'm actually going to turn this into an int and return a 1 and a 1 and a 1. And we actually don't want to return 1 here. We actually want to return suppose we do a and I think maybe that. And then I think actually if we go back to part 2, we can not do So let's do this then. Okay. So so why is that giving me 8? Maybe, but then this one is 8 and this one is 0. So that's why. No. Okay. All right. for each pattern, for each of the towels possibilities, I am asking it how many paths it can find. And if we can find a path, as is returned unchanged. I think BRWRR. Let me just see if I can think through this. So if we have BRWRR, so if we trim the first B and we pass that, then it has R, BRWRR, BR, or BR, WR, R. Ah, that's the difference here. Trim prefix. No. The problem's not here. The problem is up a layer. That's what it is. So in part 2, I need to continue here if this didn't actually do anything. So that we're not just passing it down anyway. Okay. So that's better. So if our n, our new string, is equal to the pattern, we're going to continue. And we're not quite right, but I think we're in a better position. BRWRR is 2. Which is right. BGRR is 1, which is right. GBBR is 3, but it should be 4. G, G, B, B, BR, BR, etc. But I wonder if we're getting 10 now, which means that come back to that one in a second. RR, BG, BR should be 6, and it's only 1. So C is a cache, and we want to make sure. Oh, well, hold on. Maybe I just told myself the answer there. No. C is a cache of the strings that we've already processed. And so we're passing that map in recursively. And so S is the current string. So you could think of it as, if I go back to the test input, the way it should be working is that we start first with this set here. And if we look at our test, we have a pattern of B. So this is one of the towels, right? So the first iteration through, we have BBRGWB. That's found that we are able to trim that prefix off, which gives us the second iteration of this. We can then trim B off again, which gives us the third iteration of this. And each time it's tracking, in this case, RGWB in here as seen. So it's keeping us from re-looping or reprocessing things we've already processed. But maybe that's kind of the interesting part, right? Maybe we actually don't need to do this at all. Oh, well, that's part of the problem. Um, mm, Yeah, okay. Let me bring back in my caching real quick, because now I realize that it just wasn't being called at all recursively. And so none of this was actually working. And then this has to become true again. And then we're still at 16. Great. Yeah, so I think what we actually want to do is we need to set this to an int called 0. And for part 2, uh, oof. Yeah, no, you got a point. Um, sub here actually, it needs to get through all of that, I think. Okay. So we go through each part, and each part has a sub score. Oh, and this is plus equal sub. I don't know why I took that out. There we go. We could probably clean this up, but awesome. Part 2 complete. Let's see if we can clean this up a little bit here and just make it a little less ugly. So part 1, again, pretty straightforward. If we find, we return. Not a big deal. In the other part, we can actually switch part 1 to using find to, I believe. But we would need to switch this to int maybe. And we would say greater than 0. Let's get rid of some of this logging. And let's validate that is a true statement. Yeah, awesome. Are you still struggling, Vegeta, or did you get yours figured out already, or did you come here after completing it? 338 and some massively large number that I couldn't remember for the life of me. 338 and looks right. Okay. So now we can actually reduce this, get rid of that, change this, and change that, and change this. We just have one find method, right, at this point. Yeah, it's all right, Vegeta. It happens. Like I do quite a bit of software development at work. I just don't typically do these puzzles, and so I don't necessarily understand the approach. Yeah, so we can actually probably get rid of the recursive part of this. Now that I'm looking at it. We could get rid of the recursive part if we wanted to. And so we could just, so if we wanted to, we could just add a queuing mechanism instead of recursion. We could just pop off the queue, the sub pieces, and count all of the ones that once we get down to an empty string, we're done, right? So that would be the other approach here. So maybe if we did a Gotcha. Yeah. I know I saw you join the chat a couple days ago. Um, and it's so let's see if we can actually change this up and let me look at part 2 real quick. Do I actually need to do this? Yes, because I need a different cache for the initial part. But do I? No, I don't think I do. I think actually I can get rid of all of this and just do yeah. Yeah, I don't know why I made this overcomplicated. So I'm going to get rid of that and this. And then now that we've reduced that, so instead of doing this recursively, let's do it this way. And then we can do we add onto our queue, and then yeah. We do something like this. And something like otherwise appends. This should not be that. This should just be that. Yeah. Well, I appreciate you hanging out, Vegeta. If you have questions, more than willing to answer them. I'm just kind of refactoring. I'm going to try and like just a queue mechanism here for finding where we could just put things on the queue and pop them off, and then I may actually go an index route to make it more efficient. Yeah, it shouldn't take that long at this point now that I have a solution in place. But appreciate it, man. You have a good one. Right. Okay, so then yeah, we'll call finally queue. So we just keep it pending, and then we can do the same thing here. So if we've seen something before, we return that value. Okay. So in this case, we wouldn't necessarily need that, but every time, yeah. And then this would be, um, yeah, and then this would be, and then, something like that. And that. And then I'm curious about the cache. Get rid of that. So how would the cache work in this instance? Well, yeah, there's no real way to know with a queue. So I think recursion is the better way. Or at least for me, it's what I can see. I'm not gonna work on this anymore because I think, well, you could pop it off the queue, and I think we could perhaps get to part one with just using a queue. I think part two is gonna require more than that. But let's look at day 10. What did I do in day 10? Because Pedantic did mention day 10. And so stepping through each iteration all the way to the end for each direction, I created a unique map of the trail head to the trail ends. Yeah, I don't know that necessarily applies. I'm kind of done with this problem for tonight, so I think we're just gonna abandon this idea and go with the idea of we have a solution using recursion and it works for me. So we are all done for tonight. That is day 19 in the books. We'll be back tomorrow for day 20. I hope to finish Avenue Code this year, all the way through. Even with the help, that's okay. We'll get through it and then we'll get better. So I thank you all for your time, and I will see you in a future video. Y'all have a great night.